There are 24 planets in space that likely have conditions more suitable for life than on Earth, researchers have said in a new study published recently. These more livable planets are older, slightly larger, warmer, and possibly wetter than Earth. The 24 Kepler objects of interest, which are objects may or may not be planets. Two of the 24 have been confirmed as exoplanets, namely Kepler 1126b and Kepler 69c. A study led by Washington State University recently published in the journal Astrobiology details of characteristics of these potential super-habitable planets. As per a report in Astrobiology Web, these more livable planets are older, a little larger, slightly warmer, and possibly wetter than Earth. Some of these orbit stars that may be better than even our Sun. Life could also more easily thrive on planets that circle more slowly, changing stars with longer lifespans than our Sun. The 24 top contenders for super-habitable planets are all more than 100 light-years away, but the Washington State University research said the study could help focus future observation efforts, such as from NASA's James Webb Space Telescope, the Louvior Space Observatory, and the European Space Agency's Plato Space Telescope. With the next space telescopes coming up, we will get more information, so it is important to select some targets, said Schultz-Makic, a professor with WSU and the Technical University in Berlin. We have to focus on certain planets that have the most promising conditions for complex life. However, we have to be careful to not get stuck looking for a second Earth, because there could be planets that might be more suitable for life than ours. For the study, geobiologists with expertise in planetary habitability teamed up with astronomers Renee Heller of the Max Planck Institute for Solar System Research and Edward Guinan of Villanova University to identify super-habitability criteria and search among the 4,500 known exoplanets beyond our solar system for good candidates. Habitability does not mean that these planets definitely have life, merely that the conditions that would be conducive to life. The researchers selected planet-star systems with probable terrestrial planets orbiting within the host star's liquid water habitable zone from the Kepler Object of Interest (KOI) Exoplanet Archive of Transiting Exoplanets. Now, while the Sun is the center of our solar system, it has a relatively short lifespan of less than 10 billion years. Since it took nearly 4 billion years before any form of complex life appeared on Earth, many similar stars to our Sun, called G-stars, might run out of fuel before complex life can develop. In addition to looking at systems with a cooler G-star, the researchers also looked at systems with K-dwarf stars, which are somewhat cooler, less massive, and less luminous than our Sun. K-stars have the advantage of long lifespans of 20 billion to 70 billion years. This would allow orbiting planets to be older, as well as giving life more time to advance to the complexity currently found on Earth. However, to be habitable, planets should not be so old that they have exhausted their geothermal heat and lack protective geomagnetic fields. Earth is around 4.5 billion years old, but the researchers argue that the sweet spot for life is a planet that is between 5 billion to 8 billion years old. Size and mass also matter. A planet that is 10% larger than the Earth should have more habitable land. One that is about 1.5 times Earth's mass would be expected to retain its interior heating through radioactive decay longer, and would also have a stronger gravity to retain an atmosphere over a longer period of time. Water is key to life, and the authors argue that a little more of it would help, especially in the form of moisture, clouds, and humidity. A slightly overall warmer temperature, a mean surface temperature of about 5 degrees Celsius or about 8 degrees Fahrenheit greater than Earth, together with the additional moisture, would be also better for life. This warmth and moisture preference is seen on Earth with a greater biodiversity in tropical rainforests than in colder, drier areas. Among the 24 top planet candidates, none of them meet all the criteria for super-habitable planets, but one of the planets, namely KOI 5725.01, has 4 of the critical characteristics, making it possibly much more comfortable for life than our home planet. It's sometimes difficult to convey this principle of super-habitable planets because we think we have the best planet, said the researchers. We have a great number of complex and diverse life forms, and many that can survive in extreme environments. It is good to have an adaptable life, but that doesn't mean that we have the best of everything. Astronomers have discovered more than 4,000 exoplanets, or planets outside of our solar system so far. Most of these are not particularly conducive to life. For example, planet Kelt 9b is so hot that its atmosphere is constantly melting. The darkest known planet, Trace 2b, has an atmospheric temperature of 1,800 degrees Fahrenheit, 980 degrees Celsius. On the other end of the inhospitable spectrum is GJ433d, whose discoverers described it as the coldest Neptune-like planet ever discovered. But there are also many planets within their star's habitable zone, or the just right distance conducive to surface temperatures, that are not too hot or too cold for life as we know it to evolve. Schultz-Makich and his colleagues aim to identify exoplanets most likely to be super habitable, or not only in the habitable zone, but also boasting other features that might make them a good place for life to blossom. These features included a star of the right size and lifespan, especially considering that it took complex life 3.5 billion years to evolve on Earth, and 4 billion years for life as advanced as humans to appear. A large size could mean more space for landmass and habitat. A larger planet would also have higher gravity, which would make for a thicker atmosphere, something that could be beneficial for organisms that travel by flight, the researchers wrote. A planet slightly warmer than Earth would be more habitable, given a lack of largely barren polar regions. But that warmer planet would also need to be wetter than Earth so that the deserts wouldn't dominate the land masses. A more habitable planet might thus resemble Earth in the early Carboniferous about 359 million years ago, when much of the world's landmass had the climate of a tropical rainforest. Modern-day global warming isn't good for life on Earth, both because the change is happening too quickly for many animals to adapt and because of the effects on human infrastructure due to rising sea levels. Slightly warmer temperatures, however, are not inherently bad for life. A better version of Earth might also have a slightly larger moon, or a moon slightly closer to the planet, which would help stabilize its orbit and prevent life-disrupting wobbles, the researchers wrote. The researchers come with a set of parameters to use to meet all of this criteria. According to these parameters, the perfect superhabitable planet would be in orbit around a K-dwarf star, which is a relatively small star that is slightly cooler than our Sun, which is considered a yellow dwarf, about 5 billion to 8 billion years old, about 10% larger than Earth, about 9 degrees Fahrenheit or 5 degrees Celsius warmer than Earth on average, moist with an atmosphere that is 25% to 30% oxygen, with scattered land and water. The perfect planet would also have plate tectonics or a similar geological process in order to recycle minerals and nutrients through the crust, and to create diverse habitats and topography, and would have a moon between 1% and 10% of its size orbiting it at a moderate distance. Now, it's not possible to evaluate distant exoplanets on all of this criteria. There is no way to calculate an exoplanet's landmass area, for example, much less how it's distributed. But based on factors that can be measured, such as star type and planet radius, the researchers honed in on objects that seem to meet that criteria and have been spotted by the Kepler telescope. Some of the others may be false positives that don't turn out to be planets. Of the 24 objects, 9 were orbiting around the proper type of star, 16 fell into the correct age range, and 5 were in the right temperature range. Only one candidate, KOI 5715.01, fell into the correct range for all 3 categories, but the planet's true surface temperature depends on the strength of the greenhouse effect in its atmosphere, the researchers wrote. The 24 possible planets are all more than 100 light-years away, and some are probably too far to study right now even with the strongest telescopes. Kepler 69c, for example, is more than 2,000 light-years away, meaning astronomers probably won't be able to examine it more closely for signs of life anytime soon. However, pinpointing what makes a planet super habitable is important, researchers say, because it is possible that one of these planets will be discovered within 100 light-years. If so, they wrote, that planet should be the first place Earthlings turn to find out if there is other life in the universe. And this was all about the possible planetary systems other than Earth that could contain life. If you like the information, press that like button. Also, share this video with your fellow tech enthusiast friends. And do not forget to subscribe to our channel for more such informative videos.